Assalamualaikum warahmatullahi wabarakatuh to all of you. I am Azmiah binti Abdul Ghafar. This research assisted by two other researchers, which is Mega Surya Hashim and also Amalina Muhammad Fauzi. It is an honor for me to present this research in International Conference Entrepreneurship, Management, Education, Social Science and Technology 2023. The topic of the presentation is Modular Living Wall System Response to Relative Humidity and Air Temperature in Malaysia. The content of this slideshow is divided into 5 sections according to the section in the journals. It begins with the introduction that includes with the research problem and research of the study. Section 2 provides an overview of the tree infrastructure and vertical greenery system. Section 3 highlights the research methodology used in this study. It covers the research method, the installation of the modular living wall system, the type of instrument used in data collection. Section 4 presents results and findings of the study. Finally, Section 5 summarizes the conclusion. Research problem of this study is located at Pasir Gudang, which is an industrial city in southern Johor that has high temperature and low relative humidity, which are among the climatic attributes of the city. It is possibly due to Pasir Gudang consists of 2 ports that operate more industrial activities than the Lichin area. High temperature can pose a risk to human health, while living residents of the city experience the discomforts. Meanwhile, for this research gap, the scientific literature on vertical greenery system have significantly increased annually. Nonetheless, the number of studies on modular living wall system is relatively small compared to VGS. There is little attention given to the effectiveness of modular living wall system for offering an effective thermal performance in the tropical climate, especially in the industrial cities. Which the relationship between thermal performance and plant species using modular living wall system in Malaysia has not received sufficient attention, and none of the study investigated modular living wall system plant type. These are among the variables that should be adequately considered to achieve temperature reduction. This is because plant type is a crucial component that has a specific function in the urban environment. Alright, the purpose of this study is to investigate the heat reduction using the modular living wall system from 4 plant species depending on the local weather conditions. And the research objective was formulated as follows: to achieve the research aim, which to evaluate the thermal condition from each plant species through a study of the modular living wall system in the outdoor environment in Pasir Gudang area. As cities get denser, effective emulation and measures using urban green infrastructure have been recommended widely around the world. This is in line with the 17th Sustainable Development Goals SDGs to be achieved globally and by all the UN member states by 2030. SDG Goal 13 is a commitment required to ameliorate the climate crisis. The goals is related to this research inquiry, which investigates mitigating the urban heat island effect in the urban environment in Malaysia cities. Vertical green system was the subset from the green infrastructure typology that a global trend towards increasing the higher potentials for improvement. However, despite the encouraging trends of VGS, Malaysia still lacks in research interest and industry support. Thus, VGS is a useful mitigation strategy in cities of Malaysia should be emphasized more to provide shade and act as a cooler agent. There are two popular installation methods for VGS. One is a grid facade system that installed for the climbing plants, and the other is a living wall system where the plants are contained in modular trays or felt pocket system. A number of studies on the potentials of living wall system have shown them to be more effective than the grid facade system. The experimental study was located in the administration zones of Pasir Gudang. This study was adjacent to Pasir Gudang bus terminal and located parallel to the main road. In addition, the living wall system was installed facing the industrial area in a radius of 10 km as shown in figure. The justifications of this field study has parallel to Departments of Environment Malaysia 2016, which they reported higher temperature in Pasir Gudang compared to several places. The size of modular living wall system used in this study is 4 meter width times 1 meter height. This study used a modular type that is suitable only for low height grey walls, and the wall species were selected. First, philodendron mud. Second, Philodendron cochinensis. Third, Rhabdolobit exaltata. And the last one is cordyline fructicosa miniature. These four plants were selected as they are common species that grow well in Malaysia's tropical climate, but have not been assessed in previous research in modular living wall system. The data recorded were programmed at 30-minute intervals a day. The homologer of air temperature was installed at distance of 30 cm from the concrete walls. The data logger also collected relative humidity at the same time. Both the greenery of each plant species and the bare walls were recorded. All the data were then exported into Excel to be analyzed. In this study, SPSS statistic was used to analyze the data to obtain the rigor of the analysis. This study showed a strong relationship between air temperature and relative humidity from the living wall system at the outdoor building of Pasir Gudang. The best performer for air temperature reduction was philodendron bulmark with a decrease of 2.5 degrees Celsius and contributing the highest relative humidity, 6.64%. The second best performer was Philodendron cochinensis with a decrease of 2.33 degrees Celsius, and it contributed relative humidity from the plant by as much as a 6.34%. Meanwhile, Diplodocus exaltata was the third best performer in reducing air temperature with 1.56 degrees Celsius. This means that the plant's largeness helps increase the relative humidity level to 4.23%. Lastly, cordyline fructicosa miniature was the plant that achieved the lowest air temperature reductions with 1.6 degrees Celsius. This species also had the lowest relative humidity levels by only 2.19%. Therefore, air temperature and relative humidity have a strong relationship to enhance the cooling effect at the outdoor building in Pasir Gudang. In conclusion, the present study addresses crucial concerns related to the Sustainable Development Goals (SDG), which namely SDG 13, which urban climate change in the environments of industrial cities. This research has found that in 1 meter square of living wall system from each species, it can bring substantial benefit to local areas. It improves thermal effects using modular living wall system installments on existing building and in future development. These measures would help create cities create green cities to achieve a better and more sustainable future for all. This modular living wall system installed on facade has proven that it ameliorates the high temperature of Pasir Gudang. I think that's all for my presentation. Thank you and Assalamualaikum warahmatullahi wabarakatuh.